Welcome. My name is Jeffrey. So, as mentioned before, I work in PT Hanang. It's an Indonesian distributor and system integrator. So, we have been in business since 1992. We represent mainly Honeywell. So, maybe some of you have heard of this brand. It's an American brand, and they focus a lot on control system and automation. So hopefully you will learn valuable things today on how to make your business more competitive, safer, and with better product quality. So let's have a look. Okay, so here's the topic guide. Just a brief overview of what things we'll talk about today. So the first part is we'll mainly cover the reasons. So you're probably all quite aware of what the reasons are. And then we'll go ahead onto case study and trends. So you will see relevant information for your factories. Okay, so as we know as business owners, the main thing you actually want in the end is the net profit, right? So it's a factor of three things. So revenue, as well as expenses, and finally the cost of production, which is COGS, cost of goods sold. So the first part, you obviously know the revenue is to do with how to sell more. So that's to do with branding, product, and things like that. The second part is the expenses, things such as electricity, rent, and all these other costs. And then finally is the cost of goods sold, which is how much does it cost to make your finished product. That's a component of these three things: labor cost, and then cost of waste product. So that's usually products that you already made but fail the QC, quality control process. So you cannot sell to the customer. So it becomes waste. And then the third component is productivity, in that how much can your factory make in one day or one shift. Now, these three things are usually the main reasons why a lot of factories automate, right? And this is the core of what we are trying to improve with our service. Okay, so why do so many factories automate? And you will see in developed economies, you will see there's usually more automation. In developing countries such as Indonesia and maybe Myanmar, the level of automation is less. But the reason why eventually most places automate is because, number one, is usually your labor costs become more and more expensive over time. In Indonesia, labor costs each year usually go up 5, 10, 15% every year. And then you still have to take into account things like health insurance and other things. So these things will make your production cost increase compared to automation, where it's usually initial capital expenditure, but after that, it's very low maintenance, and definitely do not go up in price every year. So the main thing why companies automate is to reduce the labor costs required for manufacturing. Number two, which is less known, is you get usually improved product quality. So we will go into the case study and you will see what I mean by this. But improving product quality is very important if you are to get the most out of your revenue. So reducing waste material and improving consistency of product so that your customers get the same product every time. The final thing usually is for safety. So we have had many customers where they get accidents, Sometimes you get factory fire because of a process that go bad. Sometimes there's things where you did not monitor the process enough, or the local operator is distracted, and so they did not monitor properly. This is a factor that can potentially be a lot of money, right? So in summary, lower cost of goods sold will mean higher net profit. Now, not all automation is the same. Now, the process that we do is the table on the left. So we call it process automation. So things like heating and cooling, batching, other industrial process, mixing, things like this, compared to task automation. So the main difference is usually with the table on the right, you can already buy a complete machine, right? So things like a bottling machine, maybe a noodle maker. So you just put in the raw material and it come out with the finished product. Printing machine. So these kind of machines, we do not do them. They are not our expertise. What we do is mostly usually a whole factory of automation, um, and then we will provide parts and components of that system, right? Now, can my factory become automatic? Almost always the answer is yes. Other than factories where you need special human skills, such as probably maybe like a cup factory where you need to make the cup by hand, like a handmade cup factory or things like that. But most factories can, and most factories always go to some percent of being automated. Some of the main actions that can go automated is things like opening, closing valves, turn on or off pumps, agitator, blower, or your boiler machines, reading all sensors on the field, temperature, pressure, flow, level, right? Things like that, as well as batching. So batching is I want to create 1,000 liter of product. That is called batching. It's very hard to do with manual labor, and it takes a lot longer per process. Now, some of the factories that we have had experience in, if your factory are in some of these in this list, then you know that this is the trend worldwide. So things like essential oil, fertilizer, petrochemical, polyester fiber manufacturing, tires, mining industry, chemical. Chemical is a big one. I don't know what the industry of chemical is in Myanmar. Uh, Fuel filling stations, power plants, palm oil mills, steel and sugar factories. So if you have a factory along these industries, then you know for sure um, a lot of the process can be automated. Okay, so we go to our first case study. So we recently did this probably about 1 year ago. It's an essential oil factory. So essential oil is like getting usually the smell of a product. For example, clove or cinnamon or coffee or vanilla, things like that. So they get the raw material, which is, for example, coffee beans, and then they want to get the chemical that has that smell, right? So the key process that they automate is a process called fractional distillation, right? It's basically uh, heating up the oil until it becomes gas. And then the gas is condensed and then it becomes a pure essential oil from that material, right? So previously, so we'll go through the process a little bit. So the material is inserted into the tank and then mixed with water. In this way, the essential oil will go into the water and then it is then pressurized to a high pressure so that all of the oil from the material goes into the water. After that, the tank is heated into a number of temperatures. So the first temperature that they heat is 100 degrees or so. So they eliminate the water. So the water is eliminated. So this process is in multiple steps. So the first step is to eliminate the water from the tank. Number two is to get the oil that is left over from the tank. So it's then heated to a higher temperature for a few hours to make sure all the oil has evaporated. And then the third phase is condensing that gas oil and then moving it into storage tank. So this process is not very complex, but it is high risk because you have high temperature, high pressure, and a lot of components need to be monitored for safety. So in the past, they have field operators to manually open and close the steam for the temperature, things like opening, closing valves for the condenser tanks, and then also monitoring the pressure and venting valves. So there's a lot of manpower involved. So when we look at the study of the before and after, the initial headcount for their operation totaled to 14 people, right? So you have 7 operators for the production, the fractional distillation component, and then you have an extra 7 people for the utilities. So the wastewater treatment plant, the boiler, as well as production manager and QC. So this is just on the plant floor. So there's 14 people. Now, after the automation, what you get is a total of 6 people, because all those people who are opening and closing valves, monitoring pressure, monitoring temperature, all of those people can now just sit in the control room looking at the computer screen, and everything is controlled from the computer screen. So there's just 2 people on maintenance. So usually there's people on the plant floor, 1 person in the control room, and then the rest is the same. So the production manager and QC is still the same. If you look at the previous slide, so on the last line, production manager and QC is still 3 people. So that's not changed. But all the people doing the process on the floor is essentially reduced to 2 for maintenance and 1 for control room. So that's more than 50% reduction in labor staff requirement, right? Now, some of the benefits of what this upgrade has bring to this factory. Now, the first part is that you get production increase. How did this happen? So firstly, because the temperature is monitored instantly and then all controlled from the one site, you can achieve the temperature a lot quicker. So maybe it took them probably before 1 hour to reach the 100 degrees. Now they can get that in 30 minutes, right? And then you also can monitor the process a lot better. And the end result is you get a lot more product from the same equipment. Secondly, waste material is reduced by 20%. What happens in this waste material? So in the past, they used to, um, because the process take a lot longer, you get a lot longer, you need more diesel, you need more water, things like this. And all of that is reduced because of automation. Number three is better consistency in finished product. So previously you get bad product if the temperature is too high. In that case, the essential oil will be a little bit damaged because the temperature is too high. And this means that they have to throw away some products because it's too hot, and then the essential oil becomes bad. Number four is better reports. They can see how long each product takes to make. They can see how much uh, diesel is used. They can see how much each day they make every day. And all of this is used as information to improve efficiency of the factory. Number five, which is also important, is you have lower risk of factory accident, right? Because in an automated system, you can have a thing called emergency stops. So for example, if the temperature or the pressure become too high, you can immediately turn off everything, right? This was not possible before because everything is controlled by each person. So if there is something wrong, one, two, three, or four or five people have to turn off everything manually. Whereas with the system, you can do that with just one click. And number six, what they didn't know was that they had some corruption in the fuel. So the diesel that go into the boiler was stolen by the local operators. So now that they know how much fuel go into the boiler, they know immediately that there was stolen fuel, and they were able to eliminate this problem, which saved the money long term as well. That's go into the operator screen. So this is a quick look of what the finished plant looked like. As you can see, it's a lot of, now I don't know if I can use the mouse here, but you see on the left, on column A, there's about 12 temperature sensor, there's pressure sensor, and there's a lot of things that like level switches and things like that. So all of this had to be controlled. For example, if you look at the left side, there's a logo called thermic. Thermic is basically the valve that controls the steam. The steam is the thing that heats up all the tanks. So that's the temperature control, where it's a lot more efficient and accurate compared to manual work. Now, this is just one screenshot of the plant factory, where you can see that everything you can see on the one screen, everything is recorded, everything you can manually you can automatically shut down centrally. This helps a lot with safety, accuracy, and efficiency. Right. So this is a financial analysis of this upgrade. So now, obviously, all the tank and all the boiler and the valves is already there. We just have to automate them. So the cost is not as high if you didn't have all of those. So you would have to buy them all if you didn't have them from the beginning. So we just had to do a minor upgrade on the plant floor, but we just add a lot of the brain, which is called control system, right? So the cost of the project, including installation, is 30,000 US dollars, right? Now, when they look at it, the cost savings of the wage cost per year last year adds up to about $25,000 per year for 8 people, right? So this was the one factor that they look at it. Obviously, there's other factors like less waste product and things like that, but we are not given information on that. So even looking at just the one factor, which is manual labor and the cost savings, you get a very high return on investment with a payback period of less than 2 years. So you get a very quick return on investment on automation. Now, not every project is going to be this high of investment return rate, but I'm just saying that it can be this high and it can be even higher. Now, the next part they're going to do is they will make a bigger, an extra line of production. So before they had two lines of tanks. This year they will add 2 more tanks. Now, when you add 2 more tanks, you don't need to buy double the automation. For example, the control system probably only go up by 30% because a lot of the components is still usable, like the computer, the CPU. The CPU and the computer is still the same, no matter how many lines, right? You only need to add on the field device and the I/O modules on the control system. So basically, with control system projects and automation, it's very flexible, meaning that you can start small and then add on to the project. That way you get better return on investment every time you upgrade. Now, a quick one on the trend in automation. Now, we all hear a lot about Industry 4.0, but what most people misunderstand is what 4.0 means. Now, let me go through all the automation versions. So Industry 1.0, this is probably 50 years ago. So before they used to use manual labor like humans and cows. And then Industry 1.0 is an upgrade of using steam equipment. After that, Industry 2.0 is using electricity. Now, in Indonesia, it is now mostly already going into 3.0, where you have process automation. So the key in Industry 3.0 is automation, right? So you have things like control system, PLC or DCS. This is quite industry-specific terms, right? And there's a lot less labor required, right? As you can see before, you have more than 50% reduction in labor headcount once you apply automation. In some cases, it can be up to 70% reduction in labor requirement. Now, the next part, which is what we have now, is Industry 4.0. What does it mean? It's Industry 3.0 combined with IT infrastructure. What is IT infrastructure? So usually what you hear the most is artificial intelligence analysis, but the most common one now is to work with ERP programs, enterprise resource planning programs. Maybe the most popular brand is called SAP. right? So it basically systems that used to be separate from each other. So usually SAP is used by the finance department, by the purchasing department, and by the executive department, right? Whereas control system is usually used by the operational department. In Industry 4.0, these two separate systems combine and they talk to each other, right? So actually, it's not really any more labor reduction because you just get better. The key in 4.0 is better information availability, right? So the executives know what's happening in the factory floor real time. The purchasing department know what is in the factory floor in real time. So they know when there's low stock of raw material A immediately. They know if there is too much stock of material B, things like that. So Industry 4.0 is the current evolution of automation. And the key uh, is always to improve efficiency and lower cost of production. But even now, 4.0 is still quite far from where most factories are at. So the main goal of Industry 3.0 is what I've discussed before, such as reducing manpower. And here are the things that 3.0 is not, right? All these things that it's not is the goal of 4.0. So if I go to the next slide, you can see in 4.0, you have all these things like efficiency analysis, plant workload analysis, optimal manufacturing. For example, should I make material A first or B first or C first? And then the next one is preventive maintenance. So is my pump or motor almost at breaking point? Should I service it before it breaks down and make my factory shut down? And then all these other analysis like waste material analysis, all of this was not possible before automatically. In the past, you would have to make a production report, a main material usage report, and then combine it into the other systems like ERP and MES systems. But now in Industry 4.0, you can combine all of this data into the ERP systems in real time, and you get a much better analysis in real time. And so this is an example of a case study of 4.0. So this was, I take this from a white paper, an industry paper. As you can see, the process is at the bottom. And before, all these process and machines, the executive at the ERP level would not know how much the machine is working. But now with 4.0, you can get all this data and then you can analyze it at the ERP and the MES at the MES level. So this is the main benefit of 4.0. Now, if we go to the next slide, I look at the reasons why a factory should or should not go to 4.0. So the first point I want to make is that companies without ERP systems and MES systems. So MES is a manufacturing planning system. If you do not have those systems in place, there is not really much benefit from going to 4.0. It'd be good enough to just stay in 3.0. Now, majority of automation costs occur in upgrading from 2.0 to 3.0. Now, the final thing that I want to note is that going from 3 to 4.0 is very complex because most integrators like my company, we only focus on the plant floor. But in 4.0, you need integrators who are very experienced with IT systems like ERP systems like SAP, for example. Now, most integrators who are doing automation do not have this expertise. Now, so if you're going to from 3.0 to 4.0, you must know that it's a whole new level of integrators experience. And a lot of projects have failed in Indonesia because uh, the integrators are not yet experienced at these two different worlds. Because most of the time, we do not need to know IT system as an automation provider. But in 4.0, you really need to know IT system, especially going with third-party software like SAP or Oracle. And this is not something that we have had or other integrators in the industry have had. So you must be careful when going to 4.0 because it's a whole level of complexity. Now here's some tips on based on the experience that we have done. Now, in general, the most important part of an automation project is the integrator, right? So the integrator is the people who put the system in for you. So, for example, if you are building a house, the key component is the 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 contractor. So the person who know how to make the floor the flat, how to make the walls good, how to make the bricks really good and strong. That's the main thing because, as you know, when building a house, you can have really good materials, but if the person installing it is not competent, you can have a very bad house, even though the material is good, because the installation is the key part. So you want to find an integrator that has a lot of experience and have a good support team, because each project is never good from the first day. It always need improvement. So the integrator needs to have a good team, an experienced team. Now the second, here's a photo of a badly done work. As you can see, uh, the cabling is not well done. So a bad integrator can mean that you will have very hard time to upgrade your system, or if something is wrong, it'll be very hard for you to find out where it is wrong. As you can see here, it's a spaghetti situation. You don't know which one is wrong and which is where. So this is a bad job, right? Now, the second most important part of automation is the control system. The control system is the brain of the automation factory. Now, the brain is the one that is on all the time and it works all the time. So in most cases, it's usually a PLC, or in a bigger factory, it's a DCS. And then you want to go with brands that are reputable with a long track record. So we bring the brand of Honeywell, which is from USA, but usually the most common brands in this field is Japanese or European, mainly Germany, as well as USA. So you want something that has high reliability and it's a proven product. Because if this component fail, your factory will not operate. So if it takes 1 day to fix, you will lose 1 day of production, and that is a lot of money. So the price difference between a cheap brand and a good brand is very small. So it makes no sense to save money on something like that. Now, The final part of the automation is the field device. So these are things like your pumps, valves, pressure sensor, temperature sensor. Now, this is the the part where there is so many choices. Usually, the best quality products are from USA, Germany, Japan. The middle quality is usually Korea, Taiwan brands, right? And then the lower price, where you have probably the uh, very, very cheap price, but also maybe the quality is not so good, is from China and India, right? So these two countries usually, for factories who are just trying out automation and they don't have a lot of a budget, they usually start off with Chinese brand or Indian brand, and then as they see the benefit of automation and they have more cash flow, they will upgrade to the other brands above it. Now, usually in most cases, this is the part where companies will try to reduce their budget because even Chinese or Indian brands, they will still work. You may not get a long lifetime, but they will still work, and the accuracy depends on what you buy. Right now, here's the other part that we see a lot of companies use to reduce the capex, the capital expenditure cost of an upgrade. So the one of the bigger cost benefit is to skip using a consultant or an EPC company. So we have worked with many companies who try to automate, and instead of hiring a consultant company or an EPC company, they hire an expert as the project leader. And this project leader is essentially the person with the design and the knowledge. So usually this project leader has worked in a factory that is already automated. So you can understand what the other companies have done, and then they will help you to make your factories a lot better. This method is a lot cheaper than going with a consultant or an EPC company. So EPC company is like the main contractor of a factory automation project. Now, as a benefit, you get not only cost savings, but your team will also know your factory automation a lot better because they execute the project themselves. And then you can bring companies like my company to do the actual field products. Mistakes on these projects is number one is always the system integrator. So a lot of system integrator, when you ask them at the beginning, do you know how to do this? They always say yes. But you really want somebody, if you get reference or case study of what they've done, so you know that they actually know what they are doing. And the second part is usually the equipment that is chosen by the integrator who is not experienced. So things like materials that are not compatible, so you get corrosion or very short lifetime. Things like materials that are not rated for temperature and pressure of your factory, so it breaks down a lot quicker. Right, so we'll quickly finish up. So this is the final case study. It's a resin plant. This is the same story. So it used to be mostly manual plant, right? So they would mix. So resin is like adhesive that you use for furniture to make the wood stick. So if you look at low cost tables, it's actually wood chips. It's not solid wood, but it's wood chips, and then it's combined with resin to become a solid wooden material. So it's a combination of 6 or 7 chemicals, such as formalin, water, nitric acid, and so on. And then you need to mix it according to customer request. So the customer with the highest quality will ask for the most active agent like formalin, so it becomes more sticky. Whereas the cheaper customer cannot afford the expensive product, so they need just add more water, so it's cheaper. So in this project, the main complexity is in batching and ratio control, because all of those things need to be mixed to the correct concentration. Now, another component is that about 5 years ago, they had one big accident where the chemical pump was not turned off, but on the other side, the valve to the tank is already closed off. So you have this situation where the pump is still pumping, but there it's already shut down. The outlet is already closed. So you get a big pressure buildup, and then eventually the pipe burst. And this caused all the chemicals to spill on the floor and cause a big problem and a factory shutdown and many government fines. So this is a computer screen of some of the factory parts. So this is the part where they're mixing the two components, which is formalin and water. So everything is configurable from the screen. And then you can even add recipes. So for example, customer A is buying the same concentration mix every time. You can put that into a recipe, and then with just one click, and you put in how many liters of chemical you want, the whole system can take care of that for you. And the accuracy is a lot better than manual work. Right, here's another part, which is all the reactor. So once they are all mixed together, they need to be heated so that the combination works well and all the chemicals are mixed together. And then here's the final part, which is what is inside the reactor, the heating reactor. So you get things like analysis, like the weight, temperature control. You have the pH analysis and things like that. So all of this you monitor, and if you were to do it manually, this would be very complex, and you need a lot of people. Right. So here's the benefit analysis of what they did on the upgrade. Number one is better safety. There is much less risk of piping burst because there is now a pressure sensor on the pipe, and when the pressure is too high, the system will automatically turn off the pumps. Number two is better product quality, right? So in the past, the recipe is probably accuracy of 80%, now becomes 95%. Number three, this is the part that is most beneficial, is the higher productivity. So before, every time they make a batch, they need to check with the lab to make sure the recipe is consistent. But usually, because it was manual, they find out that it's not enough of material A or not enough material B, and they need to redo the mixing again. Now, by doing automation, they don't have to do that anymore. You get a more than 50% improvement in productivity, because now when you make it, it finishes well and it immediately is good. So you don't need to redo the mixing again. This saves a lot of time, and they can make a lot more product without investing in more machine. The final part is obviously a reduction of workforce. In this case, it's about 40% because there's less field operators is required. Okay, now that's the conclusion of my presentation. Um, what to do next if you're a factory owner or a plant manager? Now, the first thing is usually to analyze your process. Is it efficient? Do you think it can be better? Maybe look at your competitors or look at in other countries what they do. And usually you'll find that automation is a key component. Now, maybe I don't know what the next steps are. If there's local suppliers, or maybe you can contact us um, for consultation process. Um, but the final thing I want to say is that you don't need to automate all of your factory in one go. You can start by automating maybe 10%, 20%, and then build up to more automation. You can do it gradually, and no need to do it all in one go. Yeah, that's it.